Let's use a trig substitution to solve this problem. So the only thing really stopping me from integrating right now is the square root. So I want to make a substitution that will get rid of it. Remember the famous identity that sine squared theta plus cos squared theta equals 1. Rearranging, we see that cos squared equals 1 minus sine squared. And this kind of looks like what we have in our integrand. So if x equals sine squared, then this would be cosine squared, which would cancel with the root and let us integrate. To do this, I'm going to draw our right triangle. We want sine of theta to equal x. And remember that sine is opposite over hypotenuse, so the opposite here must be x and our hypotenuse has to be 1. But then using the Pythagorean theorem, we see that this missing side is the square root of 1 minus x squared. And we also know that the cosine of theta is adjacent over hypotenuse, so the cosine of theta is actually just this. With this triangle, we're able to make this argument, and we just have to resolve dx. Remember how we said x equals sine theta. By differentiating both sides, we see that dx equals cosine theta d theta. Since we already have a dx here, we can just take this and substitute, like so. And from here, we just integrate. We're going to use a power reducing formula to simplify cosine squared. Then we're going to pull out the 1/2, and from here we integrate to get this. But we have to bring this answer back to x. First, I'm going to use a double angle identity to reduce sine 2 theta to sine theta cos theta. Since we said x equals sine theta, theta equals arcsine of x. Then sine theta is x. Cosine theta, as we previously established, is this. And that makes this our final answer.